In a world where military aviation constantly advances in speed, stealth, and technology, one aircraft is set to change the skies: the SR-72 Darkstar. This secretive, powerful plane has captivated aviation enthusiasts, defense experts, and tech futurists alike. It's been the subject of rumors and mystery for years, often compared to its legendary predecessor, the SR-71 Blackbird. Now in 2025, after years of delays and speculation, the U.S. Air Force has announced the SR-72 Darkstar is ready for action. What does this mean for global defense, and how does this new plane stack up against aviation legends? Join us on this journey into the fascinating world of the SR-72 Darkstar. As USAF declared, it's finally ready for 2025. The legendary SR-71 Blackbird traces back to a pivotal moment in the 1960s, a time of intense Cold War tensions. It all began with an alarming incident involving pilot Gary Powers, whose U-2C Dragon Lady reconnaissance plane was shot down by a surface-to-air missile over Soviet territory. This dramatic event sent shockwaves through the United States and highlighted a critical vulnerability in its aerial reconnaissance strategy. At the time, the rapid advancements in radar and missile technology by the Soviet Union posed a significant threat. U.S. officials quickly realized that the Dragon Lady, impressive as it was, would become increasingly exposed to enemy defenses. It was clear that relying on the U-2 for future reconnaissance missions was no longer viable. A new solution was urgently needed. In late 1957, the CIA approached Lockheed with a bold request: to design an entirely new spy plane. This cutting-edge aircraft was codenamed Archangel, a name that paid homage to the earlier U-2 program, which had been nicknamed Angel. The project was entrusted to none other than Kelly Johnson, the brilliant and visionary head of Lockheed's top-secret Skunk Works division in Burbank, California. The mission was ambitious, yet simple in concept: build a plane that could fly higher and faster than anything the world had seen. At the same time, stealth was becoming an increasingly critical factor. By 1959, following an important meeting with the CIA, the design was further refined to dramatically reduce its radar cross-section, cutting it by an astonishing 90%. This leap in innovation laid the foundation for the development of the SR-71 Blackbird, an aircraft destined to become a marvel of engineering and a symbol of American ingenuity during the Cold War. When the revolutionary aircraft was in its design phase, the name Archangel was initially chosen. However, as the project evolved, only the first letter A and the number 12, representing the 12th design iteration, remained from the original name. This choice wasn't random. It was the result of careful deliberation by the legendary Skunk Works team, a division of Lockheed Martin known for its groundbreaking innovations in aviation. This is how the A-12, a sleek and secretive masterpiece, got its name. The rebranding wasn't just about simplifying the name, it was also a strategic move. By adopting a more subdued and technical-sounding title, the project aligned with military naming conventions and avoided drawing unnecessary attention from foreign intelligence agencies, particularly during a time when Cold War tensions were at their peak. The cloak of secrecy was vital, as the A-12 was designed to be a cutting-edge replacement for the U-2 spy plane, tasked with gathering intelligence over high-risk areas like the Soviet Union and Cuba. However, the landscape of aerial reconnaissance was changing rapidly. By the time the A-12 was ready for action, its mission objectives had started to lose relevance. Advances in Soviet radar technology significantly improved their ability to detect and track high-altitude aircraft, making the A-12 vulnerable despite its impressive speed and altitude capabilities. At the same time, satellite reconnaissance technology had leaped forward. By 1965, spy satellites were providing clear, reliable intelligence without the need to risk manned flights over hostile territory. These developments effectively rendered the A-12's primary mission, overflights of the USSR, obsolete before it could fully demonstrate its potential. Even though the 13 A-12 spy planes were officially retired in 1968, they still had one last incredible moment of glory. In a mission called Operation Black Shield, these planes flew over North Korea at speeds of about Mach 3.1 and reached a jaw-dropping altitude of 88,000 feet. Their mission is to photograph surface-to-air missile sites in North Vietnam. Despite being retired, these legendary planes still demonstrated just how advanced they were for their time. But even before the A-12 was officially grounded, the SR-71 Blackbird was already making waves. In November 1967, both the A-12 and the SR-71 flew 3 identical routes along the Mississippi River, about an hour apart. Both planes had their data collection systems running full tilt, capturing invaluable intelligence. While the A-12's camera had a wider field of view, the SR-71's technology gave it a major edge. Not only did it capture better quality images, but it also could gather a type of intelligence the A-12 couldn't: signals intelligence. What made the SR-71 even more impressive was its versatility. Unlike the A-12, which was a specialized one-seat stealth craft used for rare high-stakes missions, the SR-71 had a 2-seat cockpit, allowing it to be flown by a pilot and a reconnaissance systems officer. It also had a larger fuel capacity, making it more suited for longer, more routine flights. In comparison, the A-12 was mostly reserved for high-priority, one-off operations, whereas the SR-71 was designed for everyday reconnaissance missions with greater flexibility. When the SR-71 Blackbird was introduced into service in 1966, it quickly became a game-changer, shattering virtually every speed and altitude record in aviation history. To this day, nearly 5 decades later, it remains a technological marvel. Designed by the brilliant American aerospace engineer Clarence Kelly Johnson, the SR-71 was part of a highly classified black project by the U.S. government, just like its successor, the SR-72. But this aircraft wasn't just a record breaker. It also instilled fear across the globe. Nations, especially China, recognized the SR-71 as a symbol of unmatched military power. With a top speed of more than twice the speed of sound and an unparalleled ability to outrun enemy jets, it truly set itself apart from anything in the skies. The SR-71 was designed to fly so high and fast that intercepting it was almost impossible. The jet cost a staggering $292 million, a price tag that reflected its cutting-edge technology and advanced materials. One of its most unique features was its construction using titanium, one of the strongest metals on Earth. This choice wasn't just for durability, it was essential for maintaining the plane's stealth capabilities. Titanium could withstand the immense heat generated by the aircraft's high speeds, and it helped ensure that the SR-71 remained difficult to detect by enemy radar. Designed primarily as a reconnaissance plane, the SR-71 was equipped with top-secret advanced sensors, a powerful radar system, and a high-definition camera capable of gathering intelligence from a range of sources. It could capture images, intercept signals, and measure radar signatures, all while flying at speeds of over 2,000 miles per hour, making it the ultimate spy in the sky. The SR-71 Blackbird was an extraordinary aircraft, equipped with 2 incredible Pratt & Whitney J58 engines. Each engine could generate a massive 32,000 pounds of thrust, allowing the Blackbird to reach speeds of up to Mach 3.2. This supersonic speed, combined with a flight ceiling of 85,000 feet, placed the Blackbird in the near edge of space category. At these altitudes, pilots had to wear pressurized suits, similar to those worn by astronauts, to survive the extreme conditions. Given its remarkable capabilities, it's no surprise that NASA, with its focus on space exploration, operated the SR-71 alongside the U.S. Air Force. The Blackbird's design was so advanced that it didn't need weapons. Instead, it relied on speed to stay safe. If an enemy missile or round was fired at it, the SR-71 simply accelerated, outrunning whatever was shot at it. This unmatched speed meant that, despite being shot numerous times, no SR-71 was ever brought down. To this day, the SR-71 holds the record as the fastest and highest-flying operational aircraft in history. It's a distinction that underscores its exceptional engineering. It remains the fastest jet aircraft in the world, thanks to its cruising speed and ability to sustain such speeds at incredible altitudes. One of its most notable achievements was setting the record for the fastest flight time between London and New York in 1974, completing the journey in just over 3 hours. Since the start of Blackbird reconnaissance missions over North Vietnam and Laos in 1968, these daring flights became a regular part of the mission schedule. Initially, the SR-71 conducted 1 mission per week, which lasted for almost 2 years. By 1970, the frequency increased to 2 flights each week, and by 1972, the Blackbird was flying daily. This intense operational tempo meant the aircraft was constantly in the skies, gathering vital intelligence. During the height of the Vietnam War, the SR-71 faced a relentless barrage of air defense systems from the North Vietnamese. They launched an astonishing 800 missiles at the Blackbird, yet not a single one ever hit its mark. The speed and agility of the SR-71 allowed it to outrun these missiles with ease. Throughout its service, the SR-71 dodged over 4,000 missiles, a truly remarkable feat that speaks to the advanced technology and incredible design of this high-flying, ultra-fast aircraft. This incredible aircraft could outrun missiles by simply accelerating to its maximum speed. Pilots often described it as putting the pedal to the metal and watching the Blackbird vanish into the horizon. However, as awe-inspiring as it was, the plane's high production and maintenance costs became a major hurdle. By 1989, the U.S. Air Force proposed retiring the Blackbird, a decision that sparked heated debates among aviation enthusiasts and experts. Many Blackbird fans firmly believe the retirement was due to a lack of understanding and appreciation for the SR-71's unmatched capabilities, both in Congress and certain parts of the military. Critics of the program often exaggerated the costs, claiming expenses ranged between $400 and $700 million annually, with an eye-watering $85,000 cost for a single hour of flight. These inflated figures didn't help the Blackbird's case, and by the early 1990s, only NASA was operating the last two airworthy Blackbirds. The rest of these legendary aircraft were decommissioned and put on display in museums, where they remain iconic reminders of a bygone era of aviation excellence. For years, nothing seemed to fill the void left by the SR-71. Engineers struggled to design an aircraft that could match, let alone surpass, its speed, altitude, and reconnaissance abilities. But now American ingenuity has taken a giant leap forward with the development of a game-changing aircraft, the Darkstar. This next-generation marvel reportedly surpasses even the sixth-generation fighters in technology and performance. Whispers of its capabilities are mind-blowing. There's some interesting secret information circulating about a mysterious aircraft that reportedly has the most powerful laser ever created. Despite these claims, the U.S. Air Force didn't officially acknowledge the aircraft's existence for a long time. They made no announcements at all. However, the secrecy surrounding this aircraft began to lift when Lockheed Martin, the company behind its development, finally confirmed they were working on the SR-72 project. They revealed that a prototype is expected to take flight soon, which sparked even more curiosity. Interestingly, the U.S. Air Force also made an official statement, confirming the existence of the Darkstar. Many people refer to this top-secret aircraft as the SR-72 Darkstar, but that's not quite accurate. It doesn't have an official name yet, and calling it Darkstar is just a nickname that's been loosely attached to it, perhaps due to its mysterious nature. Some even call it the son of the Blackbird, referring to its legendary predecessor, the SR-71 Blackbird, which was one of the fastest and most iconic planes in history. The tradition of giving military aircraft nicknames, like the F-15 Eagle or the B-2 Spirit, usually follows military protocols, historical traditions, or even practical reasons tied to the aircraft's design and capabilities. The fascinating tale of the Darkstar aircraft's development intertwines two worlds, the entertainment industry and the military. At the time, they were already in the process of developing a high-speed aircraft for the military, making this request feel almost like fate. This cutting-edge aircraft was being developed by Skunk Works, a secretive division within Lockheed Martin. The origins of Skunk Works go way back to World War II. The name was coined by the legendary engineer Kelly Johnson, who led a team of engineers working on top-secret military aircraft. Skunk Works is a powerhouse of innovation, known for its groundbreaking work in aviation technology. They are the team responsible for designing some of the most advanced aircraft in history, including the F-22 and the F-35 stealth fighters. These are not just any jets, they represent the cutting edge of military air power. Since 1998, Skunk Works has been on a mission to build a fighter jet that could achieve speeds far beyond what was previously thought possible, aiming to replace the legendary SR-71 Blackbird. However, the journey to create a new jet capable of such extreme speeds hasn't been easy. It's been filled with challenges that have pushed the boundaries of what modern technology can handle. One of the most ambitious projects in this quest is the Hypersonic Technology Vehicle 2, developed as part of DARPA's Falcon project. The HTV-2 was a rocket-launched, uncrewed aircraft designed to fly at mind-boggling speeds, traveling through Earth's atmosphere at more than 5 times the speed of sound. The project's primary goal was to collect critical data on aerodynamics, guidance, navigation, control, and the intense heat effects generated when traveling at hypersonic speeds. This project represented a leap in aviation research, as it allowed engineers to study how materials and designs behave under the extreme conditions that such high speeds create. Though the HTV-2 faced significant hurdles and didn't complete all of its test flights successfully, it provided valuable insights into the future of hypersonic flight, an area that could revolutionize travel and warfare in the years to come. The F-22 Raptor and the F-35 Lightning II are often hailed as the true rock stars of their respective generations of fighter jets. These cutting-edge machines are revered not just for their advanced technology, but also for their impressive capabilities in air combat. However, while these fighters are built for dominance in the skies, they serve a different purpose than the aircraft designed for reconnaissance and surveillance. Back in 2013, Lockheed Martin made a bold announcement that captured the attention of the aviation world. The company revealed the SR-72, the long-awaited successor to the legendary SR-71 Blackbird, a plane that has achieved almost mythical status in aviation history. Known as the son of Blackbird, the SR-72 was promised to have the same size as its predecessor, but with a game-changing twist, it would be capable of reaching speeds of up to Mach 6, or 6 times the speed of sound. Naturally, this revelation sent shockwaves through both the media and aviation enthusiasts alike. After all, the only aircraft ever known to reach such speeds before had been the experimental North American X-15, a plane that's etched in the history books for its pioneering achievements. But what stunned the aviation world wasn't just the speed. Lockheed Martin was also describing the SR-72 as a platform designed for intelligence, surveillance, and reconnaissance missions. The idea of a hypersonic aircraft used for such sensitive tasks seemed like something out of a futuristic sci-fi movie. Many initially thought Lockheed had been exaggerating or dreaming big, but as details emerged, it became clear that the SR-72 was indeed an advanced concept, a hypersonic UAV, not just a faster manned jet. The SR-72's role as an ISR platform would revolutionize how military forces gather intelligence. It could cover vast distances in no time, gather crucial data, and return without being detected by enemy radar, all while traveling at mind-boggling speeds. The main goal for the brilliant engineers at Skunk Works was, as expected, the development of an engine for a futuristic drone. But this wasn't just any ordinary engine. It had to be capable of handling multiple flight modes simultaneously: subsonic, supersonic, and even hypersonic speeds. This was no easy task because the drone had to reach design speeds that were nothing short of extraordinary. By 2013, the Skunk Works team had been collaborating with Aerojet Rocketdyne for over 7 years. Together, they worked on an innovative method to integrate a conventional turbine engine with a powerful hypersonic ramjet engine. The goal was to create an engine that could take the drone from a standstill up to speeds of Mach 6 and beyond. The engine's development started with 2 reliable and well-established engines: the Pratt & Whitney F100 and the General Electric F110 turbofan engines. These were used as the foundation for the drone's propulsion system. They provided the necessary thrust to get the drone off the ground and accelerate it to supersonic speeds, just like a typical fighter jet. But that was just the beginning. Once the drone reached Mach 3, something extraordinary happened. The next phase of the engine kicked in, possibly a dual-mode ramjet engine. This phase relied on the intense pressure of incoming air at supersonic speeds, paired with a variable air intake system. The intake was designed to create controlled shock waves that compressed the air for efficient combustion. This clever system not only helped the drone surpass the legendary Mach 3 speeds of the iconic SR-71 Blackbird, but it also allowed it to push past the hypersonic barrier of Mach 5. The second big challenge for the son of Blackbird is almost certainly going to be dealing with extreme temperatures. As the glider speeds through the atmosphere at insane rates, the combination of heat and friction could turn it into a puddle of molten metal if not properly managed. The specialists on the team will need to carefully design the aircraft to make sure it can survive these intense conditions. To keep things in check, they'll likely use high-performance composites, advanced materials made from a mix of carbon fibers, ceramics, and metals. These materials are known for their strength and heat resistance, especially when it comes to critical parts of the UAV. For comparison, steel begins to melt at around 2,500 degrees Fahrenheit, but the son of Blackbird will need to handle temperatures of at least 3,000 degrees Fahrenheit, or even more, to stay intact. To make that possible, experts will have to use cutting-edge technologies that ensure the glider remains in one piece at these scorching temperatures. Now, the United States has become the world leader in hypersonic technology thanks to some incredible breakthroughs by NASA and Boeing. For example, NASA's X-43 and Boeing's X-51 programs paved the way for understanding the challenges of flying at hypersonic speeds. After achieving these successes, however, the U.S. shifted its focus toward countering the global terrorism threat for a few decades. But things are changing again. In 2017, Rob Weiss, the executive vice president of Lockheed Martin and CEO of Skunk Works, the secretive division known for its cutting-edge aerospace projects, announced that the hypersonic propulsion testing for the SR-72 was complete. This was a major milestone in the development of the son of Blackbird. With that phase wrapped up, the team was ready to move on to the next stage, building the SR-72 flight research vehicle. This prototype, roughly the size of an F-22 Raptor, will be equipped with a single engine capable of reaching Mach 6, 6 times the speed of sound, and maintaining that speed for several minutes. Just a year later, Lockheed Vice President Jack O'Banion offered some fascinating insights into the company's incredible strides in additive manufacturing and computer modeling. He revealed that building such a complex system in the early 2010s would have been practically impossible. Thanks to advancements in 3D printing, Lockheed was able to design and build the device with incredible precision, even incorporating an integrated engine cooling system. Fast forward to March 2018, when Russian President Vladimir Putin shook the global defense world by announcing the start of an unofficial hypersonic arms race. He introduced the world to Russia's cutting-edge X-47M2 Kinzhal hypersonic missile. Shortly after, the SR-72 program, a long-rumored hypersonic project by Lockheed, seemed to vanish from public view. It was as if everything related to the SR-72, including Lockheed's partnership with Aerojet Rocketdyne, had been placed on the back burner. However, this doesn't mean the SR-72 project was entirely forgotten. Representatives from Lockheed and the U.S. Air Force have continued to mention the potential use of next-generation hypersonic vehicles, including the SR-72, as platforms for launching hypersonic missiles. But launching such missiles at high speeds isn't without its immense engineering hurdles. The extreme pressure and temperatures generated during hypersonic flight create a string of challenges that scientists and engineers have yet to fully overcome. Martin has already demonstrated that launching air-to-air missiles at speeds exceeding Mach 3 is not only possible, but a reality. This was achieved using the YF-12 prototype interceptors, which made waves in the aviation community. However, around a certain point, the SR-72 seemed to fade from public view, as if it had disappeared entirely. But then in 2021, something interesting happened. The U.S. Air Force's Profession of Arms Center of Excellence released a video showing a single-engine flight research aircraft that bore a striking resemblance to previous renderings of the SR-72. Fast forward to 2022, and things got even more interesting. The much-anticipated sequel to Top Gun, Top Gun Maverick, hit theaters, and within its action-packed scenes, audiences were treated to a glimpse of a mysterious hypersonic aircraft. Known as Darkstar, it closely mirrored the design of the SR-72, and rumors quickly swirled about the role of Lockheed Martin's legendary Skunk Works engineers in bringing this futuristic aircraft to life. Although it's highly unlikely that filmmakers managed to accelerate an actual jet to Mach 10 for cinematic thrills, the film's producer casually, or perhaps not so casually, mentioned that the U.S. Navy had become aware of Chinese satellites seemingly keeping a close eye on the Darkstar. The producer even joked about how, to avoid unwanted attention, he had to change his route to capture specific shots of the aircraft. In recent discussions, it has been revealed that the first flight of the SR-72 prototype is now scheduled for 2025, with hopes to see the aircraft enter service as early as 2030. This marks an exciting step forward, considering that back in the early 1930s, the U.S. Air Force had ambitious plans to roll out its sixth-generation fighter jet, which shows just how far technology has come since then. However, there's a lot to juggle in terms of budget and resources. The U.S. Air Force is aiming to bring not just the SR-72 into operation, but also the cutting-edge B-21 Raider bombers. Hundreds of collaborative combat drones are also in the works, all set to become key players in the future of the U.S. Air Force's fleet. With all these powerful new aircraft in development, it's clear that the military is pushing the boundaries of aerospace technology. The pressure to balance these high-tech innovations alongside existing commitments is enormous, and it remains to be seen whether the defense budget can handle the weight of these iron birds flying in tandem. The competition for military dominance is shifting rapidly, and these advanced aircraft will undoubtedly play a key role in shaping the future of global defense strategies. Thank you for watching another episode on our channel. While you are still here, click the video on your screen to see more mind-blowing videos like this one.